Glad to see you here again. Now we're going to start with the second part related to risk management. And the first thing we're going to look into are the tools and techniques that we can use to identify risk. We have expert judgments, people who know these problems, they understand what the risks are. We look also at data gathering, we look at brainstorming, checklists, interviews, all that kind of things. We look at data analysis, which is typically the RCA, the root cause analysis. We look at assumption and constraint analysis, SWOT analysis, document analysis. We also need interpersonal and team skills because we have to facilitate how to get all that information. We also have prompt lists. We have predetermined risk categories, which are PESTLE, TECOP, and VUCA. PESTLE you may know from other subjects in your classes. And of course, we have to have some meetings to evaluate and identify the risks, including some workshops. The first tool I want to talk about is brainstorming and the affinity diagram. In brainstorming, we have people thinking, and this is the thinker of Rodin, a very famous sculptor from France, and we start thinking what are all possibilities. And we may get some ideas here. So typically we can use post-its to write down the ideas that we have, and all those post-its will later be ordered. So we put all these ideas on a post-it. We have a free flow of information, of sharing information with each other. And basically what we're going to do later is create the affinity diagram. Here we're going to classify and order the ideas. So we put them in specific categories so that we can find some elements that are linking the different problems that we identified. And this is a very good technique because it may be possible that with one element we will be able to remove the causes. So basically we can find different problems that we have identified and remove the cause. So it's a very interesting element that we can use. Another very interesting item is what we call the failure mode and effect analysis, also called FMEA. You see a car burning, and basically this was the Ford Pinto. The Ford Pinto was a kind of catastrophic car developed by Ford in the United States. And with the smallest collision, the gas tank would explode and people would be killed or burned. After this, Ford was using this method. Now, the FMEA method was developed in the late 1940s by the military to assess ways to develop, let's say, kind of projects and find out what are the possible failures. Like I said, it was also used by Ford after the Pinto disaster, where Ford made a calculation how much it would cost to remediate the problem on the car and how much it would cost to pay damages to the victims. Unfortunately, Ford concluded, well, we will pay the damages to the victims because it is cheaper, and you can imagine that the people did not really like that. Now we have a system which is built around three parameters. We have the severity, the occurrence, and the detection. And every parameter is given points from 1 to 10. And we can calculate the RPM number. And the RPM number is the product of the severity with the occurrence and the detection. Now, the first thing we're going to do is looking at the highest severity. This is the effect. And we look at severities with 9 or 10, and these are on the top of the list. Then we look at the criticality, and the criticality is the severity multiplied with the occurrence. It's like a probability with impact. And here we also take the highest values. And at the end, we look at the elements which have the higher RPM. So we have those three steps. Now, detection, when we cannot detect a failure, that means that it's very difficult to detect, and we give the highest number. So this method is very interesting to use when you want to evaluate what are the possible problems you want to remediate, what is the order to remediate them. Another element is fault tree analysis, and this is basically a method which comes also from space and spacecraft, and basically it's based on AND and OR gates or NAND gates and NOR gates, and basically it finds out how is the system working. So what are the possibilities of failure? And this system leads to the development of the mean time between failure. So basically what we have is that we use Boolean logic and we look at the system failure, for example, of system A. And every element is then combined and we can see what is the probability or what is the mean time between failures for the system. It's a very interesting way to find out, for example, how much backup we need and understanding what risks are happening or are possible to happen on, for example, aircraft or some other projects. We also have interviews. Here we have to identify the right people to interview and we have to ask relevant questions. And also we have to see that the expert we're having the interviews with, are they really the experts? You have to challenge the results that you received and you have to interview people close to the issue. And you have to find out what is the value of the information that you received. And you have to challenge opponents. Be careful with supporters. Opponents probably will give you more information about the negative elements that you have, while supporters may make everything look better. And it's not really what you want. You really want to know what's going on here. The next tool that we can use is what we call root cause analysis and 5 times why. So basically, we've tried to find the real reason behind the risk. And when we look at root cause analysis, we have to go through 7 steps. First, we have to define the issue or the risk. We gather data or evidence. We ask why to identify the causal relationship. Identify the causes to be removed to remediate, and solutions to prevent reoccurrence. And then we implement the recommendation and we observe to ensure effectiveness. And this can be done, let's say, repeatedly. There is also the Kaizen technique, which is in fact 5 times why. And we're going to ask why 5 times. And every time we try to find a reason. The car engine broke down. Why did the car engine break down? Well, there was not enough oil. Why was there not enough oil? Well, the oil filter was leaking. Why was the oil filter leaking? Well, the sealing was in fact broken. Why was it broken? Because we didn't replace it on time. So basically, what we find out here is that the real reason is that the oil filter should be replaced faster. Now you can follow the instructions of the producer of the car or the machine, but basically each of those machines will be working in different circumstances. And it may be that you have to adjust the maintenance procedure because you're using the car or the machine in a different environment. Another element you may know is the SWOT analysis. You've probably seen it in some other applications. And we find the internal elements. We see the strengths and the weaknesses. Strengths are helpful. Where do we have to focus? The weaknesses are the things we have to avoid. And external helpful elements are the opportunities. What are the opportunities that we see on the market outside of the project, and what are the threats, what are the things that can be harmful for the project. Another analysis is the PESTEL, and here we're looking at the political, economical, social, technology, and legal and environment. So basically, all those elements we have to evaluate, and they have different consequences. When we do a PESTEL analysis, we will understand all these elements and how they have an effect on our project. Another element, another evaluation that exists is the TECOP analysis, which looks at the technical, economic, cultural, organizational, and political elements for your project. There is also an alternative, let's say, description, which would be technical, ecological, commercial, operational, and political. So basically there are different ways that we can use, and we look at those different parameters related to our project. So we tried to find all the elements that will have an effect or can have an effect on our project. Recently, we are adding the VUCA analysis, and VUCA means volatility, uncertainty, complexity, and ambiguity. Now, basically what happens and what we have seen in the last year is that there are events that are happening and we don't really know what to do about it. We have been thinking too much in a stable world. Now, when we see that there are disruptions, we have to use the VUCA analysis to see what we can do about it. Basically, it will lead to resilience that can be included in the system. When we have a data connection, that data connection may be broken, so we can try to find a backup to deal with that. We have to look at reserve resources that can be deployed when necessary. We have to identify clearly what you want to accomplish, because it's very important that if you want to accomplish something, you have to identify what you want to accomplish. We look at an innovation into the system, and we also look at an improvisational mindset. We may have to improvise to resolve problems. And we can also get the backup ready in case you need it. So for example, the XO, the second in command in the military, once something happens with the commanding officer, a second in command may have to take over, and sometimes it happens. Next thing to do is to look at risk qualification, and here we have 2 slides about the tools and the techniques that we can use. We can use expert judgment, we look at data gathering, and we look at data analysis. We look at the probability and impact assessment by using the probability and impact matrix, but we also look at other risk parameters, urgency, proximity, dormancy, manageability, controllability, detectability, connectivity, and static impact, and propinquity. So we have all these different elements that we can consider. We also have the interpersonal and team skills. We look at the risk categorization. We can see what are the elements defined in the RBS. We look at data representation ways. There are different ways we can present the data. And of course, we have meetings like always. When we look at the risk qualification, we are going to put the different elements in these matrices, and we identify basically where do we have to take into account, where do I have to take actions. And for the threats, the red zone means when all the risks which are in this zone, these are the threats that we have to build plans for. In the yellow zone we accept, and in the middle we watch the triggers. We will see what's happening with the risks. Are they moving to the red zone, or are they moving to the yellow zone? A similar thing we do with the opportunities, although here we want to have those opportunities that they will happen, and we will look at measures or ways to enhance the opportunity, the outcome of the opportunities. The same principle here. We have the white zone where we have to watch what's happening, what are the triggers that may move an opportunity to the top side, make it interesting for us to make plans for it, or we may have to see that we may say, okay, it's moving towards the accept zone, so we don't care about it. Another way of risk qualification are the bubble charts. Here you see different elements. We have proximity and detectability, and also let's say that each risk is represented as a bubble, and the bubble is proportional to the impact. So basically we have this nice overview of, let's say, what we are doing with those risks. And you see that large bubbles are not accepted in that area, and below small bubbles are accepted in the area. So we find out what we can do with this bubble chart. Let's now continue with the next part, and I'm looking forward to seeing you there. Thank you, and bye-bye.